Well, hello friends. Welcome back to language hacking. Today we're going to work on the Jakt programming language, and we're going to be adding references to the language. So I had a conversation with JT, and we came up with some notes about what references would look like. And I've kind of written down the basics here in the README, but none of it is implemented yet. That's what we're going to do today. But the basic idea is that we will have immutable and mutable references that are types, and you will create them by using the ampersand operator on a variable. And in order to dereference them, you would use the star or dereference operator. And then references can be used in some limited situations only, where we know for sure that it's safe. So for example, you'll be able to pass references to functions, but you can't store a reference in a struct field, for example. And we're also not going to let you return a reference from a function. So this is going to be sort of the first version of references, which will be limited for safety. And then over time, we can sort of increase the capability of our safety system so that we can perhaps have references in more situations. But we're going to start small with a small safe subset and then work our way out from there. So sort of the first version feature list that I would like to implement today is right here. So basic reference types, and then taking them as function parameters. We're not going to allow reference locals, I think. So no local variables that are references. You will only be able to pass them as an argument to a function. And no references in structs and no references in return types. And then in the future, there are a whole bunch of things to do. Like, for example, in unsafe blocks, we want to be able to convert between references and raw pointers. And once we have closures implemented, we want to make sure that references don't escape through a closure. So we don't want to allow persistent closures to capture something by reference. Anyway, let's get started. So I guess the first thing we have to do is parse reference types. Let's go ahead and just make a simple test program. I guess we can put it in samples references. And we will call it basic.jakt. Okay, so we will do something like this to start out. So the syntax highlighting here is going to choke on this, but it's going to be okay. So we'll sum together two reference parameters like this and return values. So return A plus B. Okay, and then Z is sum star A star B. And this should, of course, print out 3. And the IDE type checking and stuff is going to fail here because it uses the Rust compiler. So even after we implement this today in the self-hosted compiler, it's still going to fail because we still didn't port over the IDE extension that we use in VS Code. That's not ported to the self-hosted compiler yet. But let's just ignore that for now and see if we can parse this. So first thing we're going to want to do is parse type name and parse type name. So we want to look for a leading ampersand in a type name, and that makes a reference. So if the current token is an ampersand, then let's say mute is reference. Okay, is reference is true. Okay. And then the parsed type, if it is a reference that we've parsed, then we will simply, no, wait, we have to skip over this token right here. And then we will wrap the thing we just parsed into a parse type reference, where the inner type is whatever we just parsed. Okay, so same as above. All right. So parsed type needs to have something called reference. So references are kind of similar to raw pointers, if you think about it. And I think we can piggyback on a lot of the, or well, not piggyback, but we can make the logic very similar to how raw pointers work. So let's see, reference inner. Oh wait, this just needs to span. Okay. And in fact, maybe we should also make a mutable reference while we're here, because those will be two distinct types. Okay, so how do we know if something is a mutable reference? Well, if it's ampersand followed by mute, so mute, something like this, like result, mute I64. And then we don't even have to return that, actually. We can even say result like this. Oh, I'm not using this right. I'm not supposed to dereference here. I'm supposed to create references. Okay. Mute result. Okay. Yeah, so it's very similar to the way you create references in Rust, and I feel like it's pretty natural looking. So let's go for that as a first cut and see how it fits together with everything else. So how do we figure out, I guess, if after we've advanced, then if the current is now a mute, then I don't know, is mutable reference? We don't have to get fancy here. We can just say something like that. Skip that token. And then here, if is reference, if is mutable reference, then we will return parse type mutable reference. Okay. So will this work? Not quite. Okay. Because we've added enum variants, so now we're going to have to go and actually handle some stuff, I guess. Yeah, I think we can close that, and we will focus on this file right here. So type check type name now has to deal with reference, reference types, and mutable reference types. Okay. And this is supposed to return a type ID. So we just need to come up with a new type ID for parsed reference and mutable references. I think we can just call find or add type ID, sort of like this. So actually, yeah, let's do whatever raw putter does. We can actually just do exactly that. But instead of creating a raw putter in the type checker, we will create a reference in the type checker. So we type check the inner type, and then we create a type ID for a reference. And for mutable reference, very similar, but we create a mutable reference here as well. And of course, now we have to add to the type enum, we have to add reference type id and mutable reference type id. And because we don't have automatic equality, I bet you we have to add it to this thing as well. So if this is a reference, wait, what is raw putter? Okay, I'm just gonna keep looking what raw putter does and duplicate that. But for references, it's gonna be nice when all of this can go away in favor of some kind of automatic equality compare function. But right now we're gonna have to do this ourselves. Okay, yeah, so for reference and mutable reference, equality compare will simply compare the inner type. So whatever's after the ampersand or after the ampersand mute. Okay. Match expression is not exhaustive. Let's see. Oh, just checking if my IDE was acting up there, but no. Okay, so this is type name, which takes a type ID and returns a string. So this is sort of a how the compiler stringifies types internally. So for reference, we're just going to stringify to amp followed by the inner type. And for mutable reference, we will stringify to amp mute inner type. So will it compile? Oh, it seems like it might. Okay, so obviously we're missing a lot of stuff, but there's probably a default match case somewhere that tolerates this. So let's see in codegen type. We probably need to teach it about, yeah, because for anything else, it just uses auto. So we definitely want to handle reference types here. So what do we say? I guess we just say for a reference, it's like codegen type followed by const amp for immutable references, and for mutable references, just amp, like that. All right, let's see. I'm curious what the generated code will look like at this point. And also to see sort of what it does if we give it this little test file that I wrote. So, okay, so the compiler compiled. Let's give it the samples references basic. Okay, so lots of issues. Right here, ampersand not currently supported. All right, so that's our first problem. I think that's a parse error that we're gonna have to deal with. Yeah, let's just go for that. So we need to be able to parse these reference expressions. Parser.jakt parse ampersand. Oh, perfect. Okay. So for raw pointers, what we do is we say, if you say at raw or amp raw, so you would say something like raw foo. This is gives you the raw pointer of the value foo, whatever that is. So here we just kind of need to say if current is mute, then we're going to create a mutable reference expression, which I guess will be a unary operator mutable reference. And otherwise it will simply be, well, It's just a unary operator reference. All right. So unary operator needs to know about reference and immutable reference. Okay. And now that we've added those, I'm sure that something somewhere needs to be updated. Yeah, so another equality check. This time we don't have any inner data to deal with, so we can just say reference is equal if the RHS is also reference. Cool. Okay. Does this type check? No, it doesn't. Okay, so now we have to deal with unary op type check, which is more of this stuff. Reference goes to reference. Okay. Okay, type check unary operation. Unary operation. Think we can just type check again the same way as we type check raw address. We will just type check them, the references, just the same way for now. And then I guess here eventually we could do something like if you're trying to make a mutable reference to an immutable value, this is where we would stop you, I think. But let's not get ahead of ourselves. We'll just get this thing compiling first, and then we can start thinking about static analysis and diagnostics that we would want to emit if something is wrong with the program. Okay, so wait, let me make sure that I can see that. Okay, so now those errors are gone, ampersands are supported, but we are dereferencing a non-pointer value. Okay, so I guess dereferences only currently support raw pointers. So we're gonna have to look for dereference of a non-p right here. Oh, it's right here. Right, so if you're dereferencing something, we look at the expression. Currently, we only care about raw pointer, but now we also need to care about, wait, expression type. Oh, if the expression type is raw pointer. Okay, so if the expression type is reference, type ID. So for references, we don't need to check the safety mode. Dereferencing a reference is always safe in Jakt because it is. Not so much with raw pointers. Raw pointers can only be dereferenced in unsafe mode. Okay, so here we just need to return a checked expression, I guess. Oh, I wonder if we can do one of these. Can we do one of these? I think maybe we can. Those are kind of fancy. So, oh wait, hold on. What other errors did we have? Dereference of a non-pointer value. And then assignment to immutable variable. Variable A not found. Okay, so I probably made some mistake there. If the variable is not found, I gave it, yeah, I called them X and Y. Yeah. Okay. So let's see how this fares. Takes a hot minute to build the compiler, but once we are going. All right, so now we have, oh, I had another problem here. Z, when it was actually a result. So one problem remaining, assignment to immutable variables. So result here, this function parameter is immutable because function parameters are immutable by default. And this is actually one of those kind of sloppy, it's a kind of a sloppy area of Jakt at the moment that we need to tighten up a bit, because there is a way to say that a parameter is mutable, but the way you would do it is something like this. And, or do you have to put the mute first, maybe? Mute a non-result. A non must be before mute. Okay, so mute. That still doesn't work. Oh, I guess because result is immutable. No, result is mutable, but you dereference it, and whatever you dereference is immutable or something. I don't know. This but this whole thing, I don't like it. Like, I don't want to have to say mute result colon amp mute once again. Like, I liked it the way I wrote it before. Like, this was better. So I think we're going to take a little shortcut here and just have mutable parameter types make the binding, the parameter binding be mutable implicitly, sort of. We'll kind of just skate around the issue. So where do we do that? Type check function predecal maybe? Where do we type check parameters? So here, for parameter in parse functions params iterator. Parsed function. Parse function has parse parameter, which has parse variable, and the parse variable knows if it's mutable. So I guess maybe, okay, so maybe we're gonna have the parser sort of say is mutable is true. Let's see. Where do we figure this out? Parse variable declaration. Okay, so this is, we're parsing a function. Yeah. So I guess we can look at, let's see, let param is mutable or something. Parameter. And then we will match on the type of the var-decal parsed type. Mutable reference, true. Else, var-decal is mutable. Okay, this is really gunky, so I'm just gonna say fix me. This is pretty sloppy, but basically allow mute foo, not mute foo, like this to imply to make the parameter mute as well. Yeah, we need to iron out a stronger spec for how mutability should work for this. For how mutability should work in general. Well, I don't need to say that here. The fix me is enough. Like, this is sloppy, but we will leave it here for now. And then we can just say, you know, parameter is mutable. Yeah, something like that. Okay, so then what happens? I think we're gonna have to rebuild here. My computer is really working. Okay. Assignment to immutable variable. Okay, so let's take a look at where does that error come from? Assignment to immutable variable. Oh, if expression is mutable. Oh, interesting. So we need to check if this is a unary op expression, I guess, then how do we know if it is mutable? I guess if the result of the expression is a mutable reference. So match op. So if op is mutable reference, then true. Or wait, does this make sense? No, I want to match the type of the expression, not the op. Wait. It's not a mutable reference, it's a dereference op I'm looking at. Dereference. Okay, and else false, I guess, or else expression is mutable. So if it's a dereference op, then the result is get type expression type expr. And if that gives us a mutable reference, then true, else false. Okay, this is kind of hairy, but will it make sense? What is it even complaining about here? Expected bool got void. Oh, because I'm not yielding. Got it. Let's see. So we have a unary op of type dereference, or the op is dereference. So we're checking if the expression type that we're dereferencing, or the expression that we're dereferencing, results in a mutable reference. If so, the expression is mutable. That kind of makes sense to me. Oh, there's a much nicer way to write this, by the way. Okay, so that actually allows us to generate code. Can it compile? Not quite yet. Okay, that's fine. But I think here we can actually do this by saying is mutable reference. That's kind of cool. And then if you want it to be really Jakt-ish, you can also do this. Yeah, that's actually kind of nifty. Okay, so why do you not compile? Let's take a look. Duplicate const declaration specifier. Okay, so we're emitting const i64 const amp. That looks goofy, but that's just a warning. We also have this issue here. Indirection requires pointer operand. Okay, so let's take a look at the generated source code that we're getting. So the sum function, so we have duplicate const in the parameter types that we can definitely fix. And then, right, so we don't actually need to generate these stars. I guess that's the main problem here. So we're generating stars because we kind of dereferencing anything previously. Dereference only worked on raw pointers, and in the generated code we need stars for that. But now that we're using references, they are also passed as C++ references, so they should just be dereferenced with no character, just because that's what you would do in C++. So let's see how dereference. Yeah, so here is where that's taken care of. So you get a star always, but now we're gonna have to actually do a little bit more checking here. So I guess yield match program get type expression type expr raw putter star reference or mutable reference and nothing else. Nothing, I guess. Yeah, we don't need to try to avoid unnecessary rightward drift here. Okay, that compiled. And prints out 3. I forget what the, the program looked like. Right, so sum together 2 immutable references and give us the result 3. So it seems to actually work. That's kick-ass. But we need to get rid of this duplicate const thing. So I guess we're emitting const like that. Yep. So, in a couple of places. Okay. So normally we do that. I see. So if the variable is not mutable, then we put const. But the problem then is that the type now contains const as well. So maybe the quick solution here is to just say and not. That was kind of ugly, but whatever. Program get type for variable type ID is mutable reference. Or no, it is not reference. Mutable reference, then we're not going to do this anyway. But yeah, something like that. That's a little bit ugly, but let's just live with it for now. We can certainly improve. Okay, that's all of those. Will it build without warnings? It does. Ooh, how cool is that? Very, very cool. Okay, so I think we're going to do a commit here. This will be sort of the first cut of the reference feature, or first commit of the reference feature. We're going to do more stuff today, but this is a nice first step, let's say. So self-host, add basic support for reference types. This patch adds 2 new types to the Jakt type system. Reference, immutable or immutable reference. Mutity. Yes, they code gen to C++ references. The code generator emits C++ references for these. Yes, there's no real static analysis done yet. That will follow in subsequent commits. Okay, but oh, let's go ahead and add that sample. So can we run that test only? It gets skipped. Okay, so we're gonna have to edit the test a little bit. I already forgot the syntax for these. Expect. So you have to put something like this, right? So in this case, I expect that it will output 3. And the test passes. Yeah, so we can include the test with that commit. Great. That is just great. So let's see. I guess I can actually check some of these check marks here, just to keep track of what we're doing. Okay, so now we want to check that you don't have reference locals, you don't have references instructs, and no reference return types. So let's start with return types, maybe. Type check function. So I think when we type check a function, we check the return type here. Check return type, yes. So at this point, we can just basically just check that it's not a reference or immutable, or not a mutable or immutable reference. So maybe we should even have a helper for this. Check. What's a good thing? Check for validate. That's something that doesn't have a reference. Check. Check that it doesn't. Damn it. Disallow reference. I don't know. We need a better name, but I'm just starting with this. Disallow reference type for check for check that no reference type doesn't contain reference. Yes. And we will pass in the function return type ID, and maybe we can also get the span of it if we're lucky. Return type span. Yeah. Okay, so we have a type ID and a span, and then type ID, sure. Okay, so what are we going to do here? We're going to check let type be get type for type ID. And then we want to match on the type. So if the type is reference or mutable reference, I guess contains reference. So a first version of this can just be like this, right? But we definitely need to get fancier, because you don't want to be able to make like a tuple that has a reference in it, or like a vector or an optional reference or some sneaky thing like that. So we'll say here, fix me check for any type that contains a reference as a generic parameter. Yes. Okay, so if contains reference, then error. Reference type. Not usable in this context. That's kind of a generic message, but maybe we can still make that work. Let's see. And then we need type name for the reference type. So type ID like that. Okay, and then tests, samples, references. No reference, return types. Okay, so function foo tries to return, let's say an I64. This should not be allowed. So what would the current compiler say? Oh, it would just compile. Well, see, that's not very good. But if we build this, let's see if this is smart enough to catch that. Not usable in this context. Okay, that's good. I don't know why it doesn't show the context. Maybe the span is no good. The return type span. I don't know. But let's just ignore that right now. So samples. Oh, we have to add an expectation for the test. And I already forgot the syntax. What was it? Expect error. Hello. Let's try to run the test to see what it says. Oh, show reasons? Is that it? Oh wait, see, now you see the context. That's interesting. Wait. Wait, why didn't I see the context when I was running the thing? Okay, so it works now. That's pretty weird. Anyway, ignoring that, I'm just gonna copy the error right here and say that that's the error that we're looking for. And then it passes. Fantastic. Okay, so you can't run a test whole directory like that. That's fine, whatever. All right. Oh, and also let's update the README and say no references in return types. Check. Disallow reference types, references in return types. This patch adds a general check that this type ID doesn't contain some kind of reference type. Maybe we shouldn't allow references in generic instantiations in general, but let's just do one thing at a time. Type checking return types. Function return types. All right. No references in struct. Let's go ahead and do that. So type check struct fields. That's perfect. All right, so we are for unchecked member. Checked member type is type check type name. Okay, so right here, check that type doesn't contain reference. We will just pass in the checked member type. Do we have a span for that? Parsed var dackle span, maybe? Let's see if that works. Yeah, so the error messages now are not super tailored to the situation. That's definitely something we could improve. Maybe by even allowing you to pass like an error template or something to this error message template to this function or something like that. But for now, let's see samples, references, no reference, struct fields, let's say. Okay, so if you try to make a struct foo that had a member X, which is a reference, this should be rejected. Samples, references, no reference struct fields. Okay, reference type not usable in this context. Yes. Yes, so definitely an error that we can improve, but we don't allow you to use reference types as a struct member. We should maybe see that this also gives you an error. Do you get 2 errors? Yes, you do get 2 errors. Also, the span here is a little bit weird on these. Reference type mute I64 parsed. Var dackle is, what is that exactly? Parsed var dackle. Where are you getting the span from? Does parse type have a span? Parse type has a span. Oh, interesting. So we could actually point directly at the type if we wanted to. So that would be our would that be it? Or no? Parsed type span? I already forgot what it was called. Parsed type. Wait, what? Why is this not allowed? I don't get it. A parse type is... What is parse type? It's an enum. Oh, of course, I'm stupid. I'm trying to access the span as if it's a field, but it's actually a method. Yeah, that could be a better error, I think. It's funny how you kind of discover where we could have better errors just by using the language. It's so hard to try to come up with good errors without using the language. So I think we could do better here. Like, hey, did you mean the method span on this enum? Okay, so if we try to build, then now we mark the whole thing. Yeah, that looks better. Okay, so let's roll with that. So what do we have? Check the type doesn't contain reference for struct fields. Now we just need to have an expectation. And what was the error? I already forgot. Oh, reference type I64 not usable. Yeah, let's go with that. So the expectations, by the way, the expectations work in this way that it's just a string search. So whatever you put in error, it just verifies that this occurs somewhere in the output. And that kind of, it makes the testing infrastructure like a little bit fluffy because, you're not validating all the output. That's just how it works right now. I'm not sure it's the best approach, but there isn't like a straightforward way for me here to check for the second error. But this is where we are right now. I'm sure we can improve this as well. Just commenting on how it currently works. So Jakt test passes, great. And let's update the README. No references in struct. Boom. Self-host. Disallow references in struct fields. Okay, and finally, no reference locals. So basically, I want to prevent you from doing something like let's make an integer or something. Let's see. And then you take a reference to that. So if you were to have a ref to int, that looks like this. So we take a reference to something out here. And then we rebind it. So it would be mutable. So we would try to rebind it here. So what would happen with this program, right? This is not a nice program. Let's see. Yeah, so C++ doesn't even allow us to rebind a reference. Maybe we should allow that in Jakt, but at the moment, I think we should just disallow references in locals in the first place, and then once we figure out how we want them to work more, how we learn more about how we want them to work, then we can sort of figure out a path to having reference locals, which will probably require coming up with some way to track lifetimes so that we can make sure that you can only do things that are safe. For now, though, let's just complain about it. So let's see, type check vardecal. So if you try to make a type reference or mutable reference, or we can we even use the check that type doesn't contain reference trick right here? LHS type ID. That would be kind of nice if we could just piggyback on that. But yeah, so obviously, as you can see here, we are severely limiting what you can do with references in this first version of the feature. And we do that because we want to create references that we know can be safe. And then once we know how we want them to work, we can sort of add functionality around references, make them more capable once we know how we want to do that in a safe way. I feel like an incremental approach to safety here, where we start with the smallest possible safe set of functionality and then work outwards from that, instead of starting with a lot of functionality and trying to make it safe. That seems very difficult to me. This seems more doable. And it's entirely possible that I'm overlooking something right now, but I'm sure that somebody will let me know, or that I will think of it immediately after finishing recording the video. But this is a collaborative process, so do let me know if you have any good suggestions for how we can improve our references. So let's try to build that thing. Right, so reference type not usable in this context. Yes. Yeah, it's a crappy error message once again, but a start. Oh, skipped? Wait, why? Oh, it needs to be 3 slashes. Here we go. Yeah, so you don't get to do that. Great. Self-host, disallow references in local variable types. Yes, this is something we'll want to allow later, but let's start with a very limited but safe set of functionality and work our way outward from that. Yes. Okay, very, very cool. So let's see if we can actually use this to do something a bit more complex. So let's make a something that uses struct, for example. Advanced, I don't know, basic 2. So we will have a struct foo that has some string, let's say. So string like that, and then we would have a function overwrite that takes a foo, mute foo, and then writes pass, pass, all right, into that thing. And then we will have main set one of these things up. So mute foo is foo string fail. We will overwrite mute foo, and then print line the foo dot string. Oh, interesting. So now the argument label, it's not compatible with argument labels. So you're passing something called foo, but because you're passing a reference to it, or mutable reference to it, then it doesn't like that. Okay, so let's ignore that for now. We'll call that a fix me. So we'll put it here, references to do. Allow foo and mute foo to without argument label for parameters named foo. Yeah, that's definitely something that we should do. I think, because this looks kind of bad. So let's leave that as a to-do. Will this build otherwise? It seems to. Basic 2, and it passes. That's kick-ass. Okay, so let's go ahead and add that as a test as well. Output, pass, new line. Cool. That's pretty neat, actually. I like that. So what happens if I have an immutable foo here? Would that still compile? Okay, so Jakt does not react to that, but C++ rejects the program. So, right, it rightly complains that the candidate is not viable because the argument would lose its const qualifier. So thank you, C++, for catching it, but we want Jakt to catch it. Obviously, we'd never want to rely on C++ to reject invalid programs. Like we want anything that's invalid, we want to catch it in the Jakt compiler. So we need something here. I guess. Let's see. I'm just gonna add that in the previous commit because it came up while doing that one. Oh wait, shit. I should not have added that in the previous commit. All right, let me fix that up again. All right. So basic 2. I'm gonna go ahead and just add this test. Samples, add another small references test. And a to-do item that I encountered while writing the test. Yes, okay, so the issue now, immutable bindings. We should not be able to make a mutable reference to an immutable binding. So let's ensure that goes here, I would say. So no mutable references to immutable bindings. Yes. Okay, so samples reference, no reference, no mutable reference to immutable binding. Jakt. So this will simply be something like takes a mute I64, does nothing in particular, and then we have an immutable I0, and we try to pass that to foo. This should definitely be rejected. But it's not. So how do we reject this? I guess, let's see. So it's when you're setting up you're assigning, we're type checking a call essentially. So where would this go? Type check call. Let's see where I need to put this. Type check call. So I'm type checking the arguments to a call. Blah, blah, blah. Where are the arguments? Okay, so here are the call arguments. Here's the argument label, but we're leaving that as a to-do. Check types for compat. Okay, right. So I guess we want to teach check types for compat, that it should reject, it shouldn't allow you, or it shouldn't say that that an immutable reference is convertible to a mutable reference, because it's not. Oh, wait, if you did this right now, so if you just take an immutable reference, what would we do? Okay, then we would just reject it. That's good. So the issue is we're trying to make a mute I from an immutable I. So I guess the reference expression is the problem. Type check unary operation. Oh, didn't I mention something originally when writing this code that, oh, here's where we would check if you're trying to convert something, if you're trying to make a mutable reference from an immutable expression. So I guess here's where we would check that. So if not expression is mutable, checked expr error. Cannot make mutable reference to immutable value, let's say. So the type here would be oh, you know what? We don't need to say the type here, actually. We can just say this. This is fine for now. And we can improve the error later, but let's just start with this. Of type mutable reference. Cannot make mutable reference to immutable value. Let's see if that works. Perfect. Okay. So no mutable references to immutable values. Check. And This was the error, so let's make sure that we have that expectation listed here. Expect error. Passed. Great. Okay. Disallow mutable references to immutable values. Cool. Okay. Yes, I think that we're good here for a first version of references. I feel pretty happy with the features that we implemented so far. We're definitely going to expand the capabilities, as I've been saying over and over, but we have to start somewhere. So I'm glad that we got this started. There are a whole bunch of places in the self-hosted compiler where it would be nice to use references, but since we are still, we still have the Rust-based compiler around, even though it's only used for IDE support, I feel like we don't need to start using these in the self-hosted compiler immediately. We can start using them when we have actually transitioned off of the Rust compiler. So, like completely. But yeah, this is very cool. So this will be the end of the video. I hope that you saw something interesting here today, and I really enjoy hacking on this stuff again. I took a little break from it for a week to work on some CSS features, and now I'm back doing this. This is just awesome. So very exciting, and I guess I will see you next time. So